So managing your utility network, we're going to just be focusing on water. If you were in any one of the other previous webinars where we were talking about the utility network, we were focusing on the sanitary network as our example. So here we'll be looking at the Esri's water distribution network. So just an agenda of what we're going to talk about. So we'll do a quick overview of the utility network model. It looks like a lot of you are already implementing it, so you probably already have a good idea of what the model looks like. Talk just a little bit about the benefits of maintaining the data in the utility network, and then we'll jump into some demos. So we'll look at tracing and trace configurations, and then hopefully we'll be able to take a look at the utility network inside of field maps. So I have joined the meeting on my phone. We'll see how that goes. We were up until recently, you still needed that utility network license in order to edit the utility network in field maps, but you didn't have the functionality. Like you couldn't see containment or any of the connectivity associations, and you couldn't do any tracing in there. And now that is all possible. So we'll take a look at that and how you would make that tracing available. So just a brief introduction, the utility network, a framework for the real world modeling of utility systems like gas, water, wastewater, stormwater, and telecommunications. So you've all heard that, or maybe not, but that the term the digital twin. So where the geometric network was based on, geometric coincidence, a line snaps to a point. In the utility network, we've reduced the number of feature classes and we're modeling that more closely. And that allows us to be able to model containment associations, structural attachments. We're able to get that, have terminal connections on our pumps so that we're able to get a better real world picture of what our utilities are actually functioning like in the real world. So this is just a brief overview of the utility network model. If you aren't familiar with it and you've been in the geometric network or using the local government model, you may be used to the single feature class for each of your layers. But here, the layers are broken into a structure network and a domain network. So our structure network, we can think of it is the resources aren't necessarily flowing through them. They're what contain our network or domain network. So an example would be a manhole. A manhole is a container for a manhole channel, or a pipe casing is a container for a pipe. And then if we head over to the domain network, we have tier groups. So tier groups organize our network into sectors. For water, that would look like water cathodic protection coverage, water distribution, and water metering areas. And then our tiers basically model the hierarchy of how the network delivers the resources. And we can take a little bit of a look at that when we get over to our example, and I show you a way that you can look at your network properties. But for water cathodic protection, that's a tier, and it belongs to the water cathodic protection coverage with a hierarchy of 1 because it's the only one there. When we get into the water distribution tier group, we have the water system, which is the first level in the hierarchy. Then we have the pressure tier, which is the second, and then the water isolation, which is the third. As we move down here, we have subnetworks, which represent the topological subpart within a tier where all the features are defined by one or more subnetwork controllers. So we have quite a few examples in the water network of our subnetworks, and I mentioned a few up there: isolation, pressure, cathodic protection, and that allows us to model our system in greater detail. I used to work for the city of Battle Creek, and I remember shortly before I left, one of our undertakings was creating pressure districts, and all we had at the end was this giant paper map where we had tried to color code all of the pipes, and anytime that changed, we had to go back. We had double double layers trying to keep the, the distribution separate from the color coding of the pipes. And now with the utility network and subnetworks, we're able to model that and even to trace through that. So it actually brings a lot of value to utility management. As we get down here, we have feature classes, and then we have asset groups and asset types. So this is what our layers look like in the domain network. And this is kind of agnostic to all the utilities. You're going to see these same layers no matter what utility you're in, whether it's electric or gas or water or sewer. So we have devices, and that would include like your valves and your cleanouts and your meters, assemblies. So that could be, pressure reducing, just a collection of features that allows you to, drop a point and have those things, readily available to you so you don't have to construct them. Junctions would be things like our T's and our crosses and our elbows. Lines, that's going to include like your service lines. It's going to include your water pipes. The subnet line, we'll take a look at that in our example because you can get a lot of valuable information from that. Those are going to be your subnetworks. And we'll talk about how when you set the subnetwork definition, it can collect a variety of information about your subnetwork, and you can view that. And in the orange here, we have our non-spatial objects. So that was a new addition a little while back, and that also brings a lot of value to utilizing the utility network. An example of that might be for fiber. You may have a single cable that's represented in your GIS, but maybe you have hundreds of fibers inside of that cable, and then that's not something that you're going to represent spatially. So now having these non-spatial objects, you can model that and you can even trace through them. As we move over to the structure network, we have our structure junctions. So that would be our containers like our manholes or vaults, structure lines. So that could be our casings, structure boundaries. So that could be, lift station, pump station, things like that. So this is just a quick example. So the layer might be devices, the asset group would be flow valves, and the asset type would be an air gap, an altitude, or a check valve. So some of the benefits of the utility network. So quick information delivery with large data sets. So that was what we talked about earlier when we talked about the reduction in layers. So the data models are designed for maximum efficiency by limiting the number of feature classes, which reduces slow relationship queries. The classification system uses attribute domains and subtypes built in for each utility network feature class. It's designed to quickly traverse network features that are connected or attached to structural features. And then we can model component connectivity. So connectivity model allows you to define how each part of the system is connected. So whether that is a geometric coincidence or features that are offset, it allows you to place those in a more intuitive way, spreading them out for clarity. And then we have our non-spatial objects. We can also represent dense and complex part of the network without clutter. So a pump station or an electrical cabinet, they could have tons of features inside of them, and it's hard to represent those. So through display filters, when we're zoomed out, we could see them as a singular point. And then when we decide to go into containment, we can get a more complex view of that. And we'll see that in our field maps demonstration and also in our ArcPro demonstration. So enforcing data integrity and reducing errors. So the utility network has a built-in mechanism to detect the inconsistencies and associations among features. So it's done through network rules. If you're using the asset packages that Esri provides for you, there are already kind of industry standard rules that are in there that govern what can be connected to what. An example might be you cannot have a hydrant lead, a hydrant service connected to a system valve. That is a rule that is in there. So you either have some options there. So when you validate your topology, that'll come through as an error that there isn't a rule to support it, and you have the ability to customize this. So you either decide, that this is something that's true in your system and you can add a rule, or it's something that's a mistake in the GIS and you can correct that rule. So we use topology. That is one benefit. It tracks the dirty areas. So if you're making an edit, you'll notice that anytime you make an edit that makes a change to the topology, you'll see a purplish blue box around it, letting you know that there has been an edit to that. When you validate your topology, that's when it's going to check against that list of rules to see if what you've done is correct or in alignment with those rules, or if there's an error. If there's an error, then you're going to see a red bounded box around the dirty area, the purple area, and if not, that will go away. So another benefit would be to enable advanced analysis of your network. So the utility network, we mentioned a collection of subnetworks. So we have, like in the case of sanitary, which we talked about before, we have the collection system, cathodic protection, that are defined by the asset packages. The subnetworks can be altered by opening and closing devices like switches. A utility network uses the sources of the resource to define start points of a subnetwork and traces down to the ends of a subnetwork to discover its entire extent. So when a valve or a switch is changed, the extent of the subnetwork is recalculated. Categories are also defined on devices and enable more advanced tracing. And we'll get an example of that with the isolation trace because I have added the category isolation for system valves, which will allow us to do an isolation trace on the valves. And one thing that isn't on here that I should mention is that you do have the ability to provide like a comprehensive view of your network. So you have your map view, but you also have diagrams. And I think that keep an eye out. I think we'll do another webinar specifically to look at the different diagrams that you can create and how that can represent your system. So now I am going to escape out of here and we are going to head over to Pro. So this is using Esri's Naperville water distribution asset package. So when I downloaded that, I did go ahead and implement an enterprise utility network here. So this is the service we're looking at. I wanted to do that because without that services based, that's one of the benefits of having this be a services based architecture, is that now I can, first of all, I'm not on the server. I can utilize this anywhere. And I can also put it in field maps, and I'll show you how you can enable trace configurations, publish that as a map, and you can utilize those trace configurations right inside of field maps as well. So I did mention that we were going to take a look at this right here is my network. So I mentioned just a second ago, dirty areas. So when you make an edit, this is what you'll see. If there's an error, this is what you'll see. So one of the first things you can do when you come in is, if you want to get a good overview of your network, you can click this network properties. And in this here, it'll tell you if your topology has been enabled. It'll give you what version you're on, how many errors that you have. So if we go down here to our water network, I mentioned the tiers. You can see that the tier definition is hierarchical. This is where we can see what our tier groups are for whatever utility we're working with. And this is where we can get an idea of the tiers in our system. And you can see it's telling us that the topology is mesh. And it gives us just more information about that in general. Here we can see the rules that are defined. So we have our junction connectivity, our edge junction connectivity. So if you're looking for what rules you have inside of your system, you can access those here. Same thing with containment. We can see our structure boundaries, what's allowed to be a container, etc. So one of the ways that we can, or one of the benefits, and it's certainly not exclusive to the utility network, but the utility network provides us with attribute rules. If you're using the asset package, you get a set of predefined attribute rules that come with it that are really helpful in facilitating editing workflows and also maintaining that consistency in your data. So let's just take a quick look here at the attribute rules that we can see on the devices. So here, and these are not exhaustive, you can certainly add more attribute rules. You can modify these attribute rules to fit your needs. This one's a one that most people want when they come in here, and that's generating your IDs for devices, and that's set on all of the layers. But here we have the ability to take some information from intersecting features. So here we're grabbing the diameter and the life cycle status and maintained by from intersecting pipes. And we'll show an example of that. So, and this is using, if you're not familiar with attribute rules, it's using a calculation attribute rule. Here we have a constraint rule. So this is basically saying a constraint will stop you from making a specific edit if it violates this. So here the hydrant valve size has to be greater than or equal to 4 or less than or equal to 10, as we can see here. So that's allowing us, if we add a hydrant VOB onto a hydrant lead and we don't have the correct size, it's not going to allow us to put that on there. Validation is also going to check for errors in that, but it's not going to prevent you from actually making the edit. It's going to flag that for later. So now let's just take a quick example of how those attribute rules will work. Also, I should mention that if you do publish that, it's always good to check let's look back at that, exclude from, let's see, I can't remember the exact word of that. Yeah, exclude from application evaluation. So you're going to want to check that box just to make sure that when you publish them that everything's working correctly in your, this is more important for things that are using sequences. I just tend to check that just to make sure that when I publish that it's going to work as I expect it to in field maps or any of the applications inside of either Enterprise or ArcGIS Online. All right, so I'm going to zoom over. Oops, not what I meant to do. Okay, so we're going to do an example of the intersecting feature and just show how the attribute rules can really help kind of facilitate some good editing practices. So I'm going to go ahead and select this line. I'm going to split it. There's our purple box. So that is that is telling us that we have made a change to the topology. So I'm going to clear that right now. Now, maybe you don't want to see that all the time. So you can just uncheck that so it doesn't get in your way, but letting you know that's there. So now I'm going to search for a system valve. And I'm going to place that. Going to check the box here. We'll take a look at the attributes. And here we go. So now I don't have to add the diameter. That has carried over from the pipe. There's my asset ID. And then again, you can modify this. This doesn't have to say this. This is just what was, automatically set in there. Whatever, works for you. You can certainly do that. And and the sequence is the same. You can modify the sequence table ahead of this and start wherever your facility IDs left off. Took the symbol rotation, the life cycle status, and then brought over these two fields. Now we'll zoom in here and just to show an example of that constraint. So I'm going to go ahead and click on this valve, and I am going to try to change the diameter. right away, it's telling me that I violated that. So it's not even going to allow me to do this. And the nice thing about this being services based is that this will also carry through in field maps. It's not going to allow you to do that. You're going to get a similar message if you try to do something that violates a constraint attribute rule. So next, let's just take a look at some of the tracing capabilities here. So I'm going to go ahead before I do anything, and I'm going to validate my topology, get rid of those dirty areas, because when we're tracing, and we'll see this here, and in fact, I'm just going to do an isolation trace just so I can get the geoprocessing tool up here. Right here, we have this validate consistency, and it's checked, and it's a really good idea to keep this checked. What that's doing is that is saying that if there are any dirty areas, it's not going to allow the trace to go through. And that is because you don't know, if you have people that have done edits, you don't necessarily know if any of those edits have validated your network rules that you set. So having this checked is a good idea, but that also means that if you've been doing some editing, you need to go ahead and validate your topology. Otherwise, when you set your trace, none of that's going to work for you. So let's just take a look at the tracing up here. So we have trace locations. So we have our starting points, basically where the trace is going to start. And that can be, you can drop that on a line. You can drop that on a device or a junction. Similarly, barriers are what that's going to stop the trace. So those can also go on lines or any of the devices or junctions there. And then we have our gallery of traces up here. So these are predefined traces that Esri's created. The connected trace, that doesn't rely on a subnetwork. That just will show you, if things are connected to each other. So I've used that before, just to, if I'm doing some editing and I want to make sure that I've, connected everything together, I might do that trace. We could actually do a quick example of that. So if we want to just drop a starting point here, and then I'm going to constrain it, because if I just do this, it is going to check, everything. So I'm going to want to stop this. We'll put the barrier here. And then we'll do a connected trace. And this is just very simple. And we'll go over a little bit of what these different categories mean, because there is quite a bit here. So I'm going to run this and it should stop. There we go. Yep, it's going to stop there. So it's showing me everything is connected, so I can get a good idea that, my snapping was working. So it's a nice trace to be able to utilize. We'll go ahead and clear that out. And then let's take a look at the isolation trace. So that's one that's it is great for being able to define, what valves might need to be shut off in the event of a main break. And I know I've heard before that that people will say, oh, well, Sam knows where all the valves are, and that's great, except for that institutional knowledge can leave with people, and we have new people up and maybe they don't know every valve. It's also good for being able to potentially get a list of customers or addresses that may be affected. You can export those addresses out and then be able to let those people know that there's an outage of whatever sort, or a break, they're going to be out of water. And another way to use the isolation trace is just looking through for GIS consistency. Like, are those valves, the ones that you would expect? So you can test your system out that way. So we talked about categories. So one of the categories here is isolating. So before you can do this isolation trace, you actually have a set of geoprocessing tools here. Let's go to the toolbox in our utility network tools, and we should have, there we are, set network category. So this is where we're going to want to pick the category and pick what layer that category goes to. So it's like a tag. So what I did is I ran this tool and I said isolating equals our system valves. So that is the first step if you want to do an isolation trace, is that you have to define that. And then we can go ahead and let's just do an example. Okay. I'm going to make sure I clear that. I'm going to drop my starting location. I'm going to click on this and do an isolation trace. And then I'm going to choose my domain network, which I just have water, so that's all I'll see. Some people will put all of their utilities in one utility network. I've talked to Esri. The only time you would do that is if there was a need to trace across, like say water and electric. But if you had them all in the same utility network, you would see more domains. Then I'm just going to do the water system tier to keep it simple. And at first, I'm not going to include my isolated features. So if I just ran this right now, I'm not going to get the results that I expected. Here we are, this traversability. So there is a tool called set subnetwork definition that you will do upon creating your network. And you can alter the subnetwork definition. I just accepted the defaults when I set my subnetwork definition until you've determined that you have more conditions that need to be met. But basically, these are traversability, differing from connectivity. Connectivity being what can connect to each other. Traversability, is there a path between them based on the connectivity that you've set? So here, if the device is closed, it's going to stop. If it's not in service or to be retired, it's going to stop. And if it's cathodic protection, it's going to stop. So those are the defaults that were set when I set the subnetwork definition, and that carries over to tracing. Now, if we go to our filters, this is where we need to set this. So we need to go down here, and I'm going to say that the category is equal to isolating. And I'm just going to go ahead and run this. And now we can see it's showing me which valves I need to shut off. So now I'm going to take this a step further, and I'm going to say that I want to include the isolated features. So that anything, well, this is not a great example because we don't have any. Well, this will work. So we're going to get anything that's been affected by this outage. So I'm going to go ahead and run this one more time. If you go over here to your selection tab, you can see your numbers here. So I've got 8 water devices. If I expand that with my subnetwork groups, I can see I've got a fire hydrant. So here's my service valves right here. So I could export this out in the attribute table. Right now, this doesn't have a field called address, but you can certainly add a field for addresses for all of your service valves, and then you could export that out, and that would be a list of people that you might need to notify. And then if we want to look at one step further, we have output down here. So this is where we can define what we actually want to return. So maybe, yeah, I want to return all of the participating, the affected features, but maybe I don't really want fire hydrants. So I can go ahead and scroll down through this and go to service connections. And I can do residential. And then we'll do service valve. This will get into why it's good to set trace configurations on these. Well, we'll just do this and we'll run that. So there we go. Now we have only returned our features here. We have 2 service connections. So that allows us to limit the output of that. So I mentioned trace configurations. Trace configurations, so some of these traces can get very complex, and this may not be something that you necessarily want your end user to have to do every single time. And that's where trace configurations come in. If we go back to our geoprocessing tools, we can go under the utility network and we can, oh, where's our trace configurations? Here they are. So we can add a trace configuration. And so basically what that's doing is configuring these traces exactly how you want it. And then all your end user has to do is drop their point, and it allows you to save complex traces. When you do create the traces, this is where you're going to find them, under here and under sharing. So when you want to take these these are two traces that trace configurations that I saved, one just being a general isolation trace and one with the addresses as the outputs. So if you want to have this in field maps, you need to check these boxes, and then you need to publish a map from here. So you would check these boxes, you would click OK. When you went to share, you would share this as a web map, and that's what you would use in field maps, and that's where you'll expose your trace configurations. And even on a pro level here, if I go back to, say, run this isolation trace again. So I'm going to do isolation trace, and I'm going to say use a trace configuration. And I'm going to do the one with addresses. And as you can see, they have no complicated fields that they even need to do. So we'll run it. And there we have all the features returned. So it's just a nice way to have that available for them without having to go through everything. And just to... So we went through the traversability, what that looks like. We went through the filter barriers, the filter function barriers. So this, stop at this. This is more, stop when as the trace is proceeding, some kind of function is derived, and once that value is met or exceeded, stop. So that might be an example of add. Oops. Shape length, and then you could do greater than, or we could do greater than or equal to 400 feet. So that's gonna, the trace is gonna stop once it reaches that. It's gonna stop at 400 feet. So it can get kind of complicated to understand, exactly what all of these mean. Then we get down to this last one, functions. And an example of this would be to return some sort of calculation in the messaging. So you could do add shape length or count shape segments. And then when you ran this, when you went to your details, it would add that up for you. So it can get very complex. It can be very simple. Having trace configurations allows you to have that functionality inside of field maps, and it also allows you to make it easier for your end user. So lastly here, I'm going to stop sharing, and I'm just going to quickly show a field map functionality. Sorry about that thing at the bottom. Wasn't able to figure out how to get that to go away. So I'm going to use my bookmarks here. We'll look at the trace. So I'm just going to zoom in to this area. And all I need to do is I'm going to just click on one of these pipes where I want to start my trace. So I'm going to pick the distribution. So now if you scroll up and you go to the very bottom of this, you're going to see these where it says isolation trace field maps. Those are the trace configurations that I published in the web map. So I'm going to go ahead and do the isolation trace minus the addresses. So now it wants to know where I want to, drop the point. So I can hit continue up here at the top. And there I go. There's the valves that I need to close in order to shut water off to this area. And lastly, I just want to show what containment looks like, how we weren't able to do that before. Again, you need utility network licensing for this. So I'm going to go over to my pump station. So this pump station is the green is a structure boundary. And we can see some information in there right now. Now I'm going to click on the green boundary. And if I scroll up here towards the bottom, I'm going to say view contents. And now I can see the detail inside of my pump station. And I can click on any of those and get more information. I can start editing. It's great to see that functionality. Also, we have the ability to have our structural attachments and connections shown. One last example is I will scroll over to our meter station. And this kind of shows the complexity of it. So we have the structure boundary. I am going to click the blue structure boundary, this vault, and I'm going to scroll down and view the content. So now I can view the content even further. So containers can be inside of containers. There's 33 items in this container. And now I get a full picture of exactly what's happening, and I can scroll through this. Just some really great functionality to be able to see this, to be able to utilize our traces inside of field maps. So it's definitely coming a long way. I only see it getting better from here.